Here you have to answer A, B, and C, or D, E, and F. So you just answer all of them, and then in the GC hall you choose yours. Okay. Question 7A, Romans 1 states, define density and state it SI unit. So density is just the mass per unit volume of a substance. That's the definition. Mass per unit volume of a substance, and its SI unit is kilogram per meters cube. Kilogram per meters cube. That is. Now, what about Romans 2? Romans 2 is an experiment. The question is to describe an experiment to determine the density of a piece of stone, an irregularly shaped object, including. So in the experiment, you have to talk about the list of apparatus needed, a diagram of the setup. So let's start with the diagram. So if you want to measure the density of a piece of stone, it means the mass of the stone should be known, and the volume of the stone should also be known, just like on the formula. So you need the mass and the volume. So the mass of the stone can be measured on a normal balance. What about the volume? To obtain, since it is an irregular shape, there is no formula to obtain its volume. But we can use the idea of water in a measuring cylinder. So if you place water, let's say half filled, in a measuring cylinder and measure its original volume V1, and then in the same measuring cylinder you attach a stone, the stone, let's say an irregular shape, to, let's say, a rope, and then introduce it gently into the water. You realize that the volume of the water will increase from V1 to a certain value V2. Now, just by taking V2 minus V1, we can obtain the volume of the stone if we neglect the volume of the rope. So the volume of the stone V will just be equal to V2 minus V1. Now we know the mass and we know the volume. So density is just equal to the mass of the stone divided by the volume of the stone. That means density is just equal to the mass of the stone over the volume of the stone, and which is measured in kilogram per meters cube. Okay, B, still on question 7, B says, Romans 1 says define pressure. Okay, we all know that pressure is the force acting normally per unit surface area. That is the definition of pressure. The force acting perpendicular per unit surface area. And then its SI unit is the Pascal or the Newton per meter squared. Okay, B Romans 2. Here we have a question. The question is a rectangular block 0.101 by 0.02 by 0.04 all in meters has a mass of m, is given as 0.064 kilograms. So here is the length of the cube, here is the width, and here is the height. So 0.01 meter by 0.02 meters by 0.04 meters. It means the block can be something of this form. So here is the length, here is the width, and here is the height. The length, the width, and the height. The question says, calculate the area of the largest values of the block. The height and the width are larger than the length. And the question says, calculate the area of the largest face of the block. It means the largest face of the block is the area made between the width and the height. The width and the height. Here is the largest surface of the block. And for primary school, we know the formula is just width times the height. This length times this length, width times height. That is 0.02 times 0.04. If you calculate, you obtain like 0.0008 meter squared. So that is the value of the area. Okay, Romans 3 says, calculate the weight of the block. Okay, the weight of the block is just equal to the mass of the block times gravity, and gravity in the ordinary level is taken as 10 meters per second squared. That is gravity. So the weight of the block is equal to the mass of the block 0.064 times gravity 10. That will be 0.64 newtons. Weight is measured in newtons. The last question here says we should calculate the pressure the block will exert on a surface when lying on its largest surface. Here is the largest surface. We have already obtained the area of the largest surface. So Romans 3, from our previous formula, pressure equal to force over area of the largest surface. Force is the same as the weight of the rectangular block if it is placed on its largest surface. It means pressure here will be equal to the weight, which is 0.64 over the area, which is 0.0008. So using a calculator, we obtain 800 Pascal. So that is the pressure. Okay, question 17. That is under elasticity. Romans 1 says, define elastic limit. Okay, so what is elastic limit? You all have elastic material. If you check an elastic material to a certain point, it may not regain its elastic or its original shape again. So how do you define elastic limit? Elastic limit is just the maximum force a material can withstand and regain its original shape after the force is being removed. So that is elastic limit. Romans 2 says, a copper wire is stretched by a force which is gradually increased in magnitude until the wire breaks. Okay, sketch a force extension diagram for the wire. On your graph, indicate the elastic limit. So, If you want to sketch a first extension graph of wire, knowing that copper obeys Hooke's law, you first obtain a straight line, which means force is directly proportional to extension, that is Hooke's law. At a certain point, you obtain a point of proportionality. The curve may turn a little bit, and at a certain point, you obtain the elastic limit. After that, the curve can no longer be normal. So here is our elastic limit, and here is the point of proportionality. At the point of proportionality, the material can still regain its original shape. But at the elastic limit, the material can no more regain its original shape if it exceeds the elastic limit.
Voilà, bon.
Okay. Question 7. Question 7D. The question is under waves. Yeah. Roman 1 says you should define a longitudinal wave and give an example. So what is a longitudinal wave? A longitudinal wave is a wave that travels parallel to the direction of the production of the wave. It means it travels parallel to the direction of the vibration. If this is the direction of vibration, that is the source producing the wave, if that is the direction, the wave will also travel in this direction. It means parallel to it. If you are asked to define a transverse wave will be the one which travels perpendicular to the direction of the propagation, or to the direction of the production of the wave. So that would be a transverse wave. So a good example of a longitudinal wave is sound wave, and a good example of transverse wave is light. So all electromagnetic waves are transverse waves. We have microwave, radio wave, ultraviolet, and so on. They are all transverse waves. Question 7D, Romans 2, 2019 says you should describe an experiment to measure the speed of sound in air. So this experiment will be based on a clapping method. We use the clapping method. Here we need two guys or two students, one with two pieces of rod and the other one with a stopping watch. We also need a wall at a certain given distance or known distance. The distance is known to the two students carrying out the experiment. So the first student claps the two rods so as to produce sound. The sound will travel in this direction. When you come into contact with the wall, the sound will be reflected backward. Once the second student hears the sounds back, he stops the watch. So the time taken for the sound to leave the two students, move toward and then backward, is noted T. And the distance between them, which is D, is noted D. But what is the distance traveled by sound? Sound goes and comes back. It means it travels 2 times D. So the distance moved by sound is equal to 2D. Now what is the formula to obtain velocity? Velocity is just distance covered over time taken. So that is the formula you use to obtain the velocity of sound wave. So this is a particularly easy method you can use in the DC form. Okay. Still under question 7E. The question says define wavelength. So this is under waves. So what is wavelength? Wavelength is generally denoted lambda. Wavelength is just the distance between two successive points that are in phase in a wave profile. So that is the definition of wavelength. Plane waves generated on a surface of a ripple tank are found to travel a distance d of 0.74 meters in t equal to 1.6 seconds. The distance between a crest and the adjacent torque is 0.06 meters. Calculate Romans 1 the average speed of the wave. The speed of the wave v is just the total distance traveled by the wave over the total time taken. So that is 0.74 on 1.6. Obtain 0.46 meters per second. That is the average speed of the wave. The next question is to calculate the wavelength of the wave lambda. How do you obtain lambda? Lambda is just equal to 2 times the distance between the crest and the top. That is 2 times 0.06 meters. That is 0.12 meters. That is our wavelength. The last question here says, find the frequency of the wave. From the wave equation, velocity equal to wavelength times frequency. We make F some formula, frequency is equal to velocity over wavelength. That is velocity of this wave 0.46 all over the wavelength 0.12. It means 3.8 hertz per second. That is it.
C'est bon.
Now we have question 7F. So question 7F is under optics. And the first question is to define the principal focus of a converging lens. Here is a converging lens. We can also represent it like this in diagrams. That is a converging lens. And here is the principal focus, F. Now how do you define the principal focus of a converging lens? There is just a point on the principal axis, this point, whereby rays of light incident and coming closer to the and close to the principal axis will move a focus after refraction by the lens. Romans 2 says, draw a ray diagram to show how a converging lens is used as a magnifying glass. Good. So we draw the diagram together. If here is a converging lens and the principal axis, here a focus, 2 times the focus. The distance should always be the same. Here is F prime. So here, it suffices for us to place the object between the origin and the principal focus. If I place an object here, here is my object. As we said, the object will move towards. Let's take it up. The lens and will be refracted by the lens, a focus, and then this part will move towards the center, looking at the rays. They can never meet on this side, but if you look at the imaginary part behind the object, you realize that they will meet a certain distance behind. since this is the image, you use dotted lines to represent it. So if you use a good sheet of paper and a ruler, you obtain something of this form. So that is how a lens is used as a magnifying, or is used to magnify objects.